All right, so One Conference, thank you for having me. Today I want to talk a little bit about a part of the web that not a lot of people realize that's there. We know supply chain attacks. We've seen supply chain attacks. There's a ton of really interesting articles on this, and I've got some examples. But we don't really look at it from a web perspective. And we've been looking at this for a long time. Like Peter said, we collect data. We've been doing it for a decade now. And we have a lot of information on this, and in today's presentation, I just want to take you through some case studies we've done, but also on the technical level, what it looks like and how it's been abused. So yeah, my name is Jonathan Kleinsma. I'm the head of threat research, and the list there is more the function of the entire team. Obviously, we do intelligence, we do gathering, we do classification and curation of the information we have. But one important part, which I think is the last or the second last one, is the product part. A lot of people think about threat intelligence for cool reports and really interesting presentations, and sure they are. But a really important part for us is also improving products. It's also pioneering new products. Certain features in our product came from threat research because of what we were seeing, especially with some of the content I'll be talking about. So, as Peter said, we've been around since 2009. We collect data, or we do internet reconnaissance. That's another way of saying it. We build data sets. We have a lot of data sets, and it's anything from the very standard passive DNS that everybody collects, to whois information, which tells you who owns a domain or who's hiding behind a privacy service supposedly owning a domain. We store this information over time. We built this as sort of a time collection so we can go back in time. But most importantly, we don't throw away data, because one of the problems is you can collect a whole ton of data, but we want to have a historic view. Because sure, it's really interesting to detect an incident at the point it happens, but if it's something new, you don't know about it. If you don't know about it, maybe it has something really smart like a machine learning thing. But a lot of times what we do is we look at the history. We want to know what happened before or how did something happen. Now with that data, just to give some examples of what we can also do, is we can build footprints of organizations. So if you tell us what the name is of your company, or if you're a large organization, you have different brands, you give us the name of your brand, we will figure out domains you own, we will figure out IP space you own, maybe you've got some websites you didn't even know about. Maybe somebody in your organization is registering domains with his work address. We've seen all of this. And we basically link all this information together, and that's what we're really good at. Storing information over time, correlating it, and being able to build a picture. And with that comes a whole lot of other products, but I'm not a product guy. So I want to talk about supply chain attacks. They're really interesting on very different levels. The basic concept, obviously, is piggybacking, or a piggybacking method of intrusion. You get in by just hopping on something and just using it as sort of a delivery method. And the basic concept is you have a supply chain, somebody does something with it, it gets contaminated, it is affected, and it continues on, and people don't know. That's the basic of it. And you can do it in a lot of different ways. You've got physical supply chains, which are really interesting. And this is one example of the Snowden leaks. So the NSA, obviously they're an intelligence agency, they do supply chain attacks. Now internally they have something called SIT Today. It's like their internal sort of bulletin for cool projects they have, cool research they do. And one of them was stealthy techniques can crack some of SIGINT's hardest targets. And in that article they described on a technical level what they're doing, but also kind of show off to different departments. And what you can see here is the actual supply chain attack they're doing. In this case, it's on Cisco appliances. So you actually see somebody with like a paint stripper heat gun trying to remove the tape to keep it intact. They open it up, keep all the seals intact. And the other picture is the load station where they actually implant, beacons, or you could call it malware, whatever you want to call it, implants. They put them on the devices, they put them back in, they reseal it, it looks like new, and that's their supply chain attack. And that's a physical one, and that's one we've known about for a long time. It affects companies in different ways. Some of it is espionage, some of it is if your supply chain is interrupted, you lose money. Now there's also software update hijacking, which is sort of the software supply chain. We've seen examples. All these three were compromised. All three were compromised by the same group. All were compromised through software updates. Some were seen at the moment it happened, some were seen way later. But it's pretty interesting because those are big names, but also big applications. So CCleaner, everybody has this. And the funny part about CCleaner was the attack was a shotgun approach. so they would affect everybody, but they had a stage 2. They would do some filtering, and only if you were in their target group, they would actually infect you with stage 2, which would be the actual sort of backdoor implant. So it's a shotgun approach through a really widely used piece of software, getting in, seeing if you're on the right target, and then if you are, you continue, you put your implant on there, you're done. Now there's been more, and this kind of tags on to Robert's talk of this morning. This is also software, but this is software for engineers in critical infrastructure plans. All these screenshots are updates or installation screens for pieces of software an engineer would use to control a machine, update a machine, change the way it would be set up, speeds, whatever. They could change configurations. They were targeted by a group that uses the Havix malware or Havix Red. What was interesting, all these companies have European, US, Asian customers. They have different setups for their update server. The only affected update server was the European one. They had access to all the other ones, but they only targeted engineers in Europe doing anything with ICS. So it was a pretty interesting case. Now, and then you have the web supply chain. It's not really talked about too often. Not a lot of people really realize there's one. A lot of people think about the software you're running on your server for your web server. So your PHP, your Apache, that can be from a software supply chain hijack or attack, can be affected. But the web actually also has it. We've got analytics, because everybody wanted analytics. We've got ads, because everybody wants ads anywhere, because you want to monetize your website. You've got CDNs, which are really interesting for load balancing and making sure your website is reliable and available everywhere at any time. We've got cloud providers where people host content. It's basically any external service you have for your website can be affected, because all those basically partners of yours will be running part of your website or will be adding something to your website and affecting not per se you or your website directly, but anybody who visits it, which is, well, it's what your website is for. You want to have people visit your website. So if you think about it, client-side integrations are nearly invisible to you as the owner of the website. You put in your Google Analytics tag or your Google Tag Manager tag or your ad tags. You don't see what happens. That's up to the visitor. They visit it with their browser, they get ads, they get anything you want. There's a lot more than ads. There's loyalty programs, so retailers that give you points for spending money with them and you can reuse those points. They are also third-party suppliers. We've seen them compromised. It's just part of the web, part of people building websites. Now, it runs outside of what an organization would define as an attack surface, which is also pretty interesting. They have really good insight into their own sort of attack surface. They know what they own. They know the servers, they know what they have running on there. If it's outdated, they'll update it. It's all from sort of internal. They don't really have an external view. If they do, they probably do some scanning to see if they have open ports, if they expose something. They don't really see these third parties as an attack surface, but they are. If they get compromised, your visitors get compromised. And sometimes it even affects website owners themselves, and I'll explain it later. And all these things can have pretty devastating effects. And we've published about this, and I'll show some case studies of what happens. So about a year ago, we did a publication. I think it was a few months before this last year, for Ticketmaster. Because Ticketmaster made an announcement that they were compromised, which it happens. A lot of companies sadly get compromised. But what was interesting was the way they sort of said it happened. So they found the compromise because somebody told them. That's part one. A bank reached out to them because they saw fraudulent transactions on cards, and they were able to pinpoint through just correlating where those cards were used. They found one common point, which was Ticketmaster. So a bank reached out to them, multiple banks actually, and they said, something's going on, you have a breach somewhere. So they did an investigation, and they were actually able to identify a third party, so a supplier breach that happened. They published about it, they identified the supplier, and they said it happened from February until June 2018. The problem was the bank said it was way earlier, and they said it also continued on a little bit longer. Then we came in, and people hadn't really seen much of us publishing about what actually happened before. We did, but we decided to publish the full story on what happened with Ticketmaster. And we extended their timeline with about 3 months, what they weren't aware of. And we also identified the attackers, which was a group that we've been following for quite a long time, a few years before they actually got to Ticketmaster. So Ticketmaster was compromised through their suppliers, so their web supply chain, not a software supply chain. There was no internal breach, which is what you most often see when there's a credit card breach. They were compromised through a company called Social Plus and Inventa. Both do web things, to be honest. Social Plus was, I think, an analytics provider at the time, and Inventa was a loyalty program. They integrated with the website. Now, Social Plus was compromised in December of 2017, and they were compromised throughout June 2018. They were not targeted for Ticketmaster, and that's sort of an important note, and I'll highlight it better in the next slides. Inventa was compromised from February 2018 until June, and they were specifically targeted because Ticketmaster made use of them. And to explain, Social Plus was compromised back in that December timeframe, 2017. And what we would see is we would see different scripts. So the stuff on the right is JavaScript files that would be put on websites that make use of Social Plus. And we would see, with those timestamps, we would see them modify these scripts. So they would go one by one. December 6th, they did one for Hotel, which is kind of like Booking.com, but with the interface of Skyscanner, if that makes sense. It's just a booking website. They don't actually process the payments because you get linked through as a referral to the actual hotel to do your booking. So there's no skimming of cards there. December 9th, they went after Klook, which is another travel agency website. Now after that, they did a couple websites I honestly don't know. And then December 22nd, they hit Ticketmaster Germany. And then January 15th, which is a way bigger time frame of the time in between them modifying scripts, they went for Ticketmaster Australia. And then they stopped. They didn't go over any other customer Social Plus, and they have a ton. They have a couple hundred. They didn't modify any other script, even though they had full access on Social Plus infrastructure. And that stayed like that. That was it. They had Ticketmaster Germany, they had Ticketmaster Australia, and they stuck with it. Other Ticketmaster websites weren't affected at that time. Now, what they did, so if I go back, January 15th was the last date stamp we have for them modifying one of the scripts. It wasn't until February 22nd when we saw Inventa. So they spent their time from January into February to sort of figuring out what Ticketmaster was using on their website. From those third parties that Ticketmaster was using, they figured out Inventa was, in some way or another, they haven't disclosed it, vulnerable. And they got in, and they only, again, went after Ticketmaster scripts. So they completely sort of had a very narrow focus. Because if you look at Inventa is huge. Like really, really big. They have over 500 customers that make use of them. You might recognize a few names on there. There's ASN Bank, a bunch of other things. This is just a small snippet. 500 potential websites you could do skimming on, so collecting card data. They didn't go for it. They only went for Ticketmaster. And we know from this group, they don't do this normally. They do supply chain attacks. They do not target. It wasn't until they noticed they had Ticketmaster, which is a really big deal for them, because their traffic basically shot through the roof, they decided to completely focus on it. They figured out a good tactic. They're still using it, which is supply chains. But they just realized, hey, we've got a really big one here, and we can focus on it and get way more out of it. Now, there's another one, and I don't think anybody has heard of this company unless you might have read our report. I don't know if there's anybody who knows them. Could you raise your hand? Because I don't think anybody here will know them. No? So, FlashTalking is everywhere. An average website you will be visiting, FlashTalking will be on there. FlashTalking is sort of an analytics provider. They also do provide ads, and they do a bunch of tracking. And ads are big business. That's one thing, obviously. However, FlashTalking is widely distributed because they help the ad ecosystem. They write functionality for other providers. They write functionality to get certain things going in the browser. And they're also a lot of times the stepping stone to deliver ads from different platforms, or they are brought in by different platforms. So you might not have FlashTalking on your website. You might have it because you're using another provider. So it's even a supply chain attack on ads, technically. Now, At the time of the compromise, we identified well over 100,000 websites that were affected with malicious script loading through FlashTalking. Again, they were skimming credit cards. The only thing you have to realize is that if you do ads, or if you attack ads and you use ads to load malicious scripts, you won't always get on a page where payment information is present. So it's sort of a shotgun approach, and that's what this group sort of does. You go for supply chain, you put it in really big, and you see what happens. Now, FlashTalking became aware of the breach. We don't know how. We're not sure if it's on their own. It might be. They did clean up on their own by just setting up completely new servers and just trashing all the old stuff, which is a really good approach if you don't have the capability to do good incident response on your own. Now, we don't know the impact. We know the impact from our side because we crawl a lot of web pages. We do about 2 to 2.5 billion a day. We don't know everything. The web is really big, so there's probably way more than what we observed. The company did reach out to us because when we published about all the third-party suppliers that had cleaned up. So we didn't put anybody in our reporting that was still affected because that's kind of bad. You want to do outreach, you want to make sure it's solved before you say anything about it. They went back into media saying nothing happened. It's fine, no, they made a mistake, they called us out, it's wrong. They then reach out to us to basically sort of put their foot in the ground and say, you guys didn't see anything, prove it to us. So we sent proof, and then we never heard from them again. It's one way of trying to sort of bully people. It happens more often. We don't publish about a whole ton of these cases because the companies aren't very happy, which is logical, but there's different ways of reacting. Now, what's kind of interesting with FlashTalking, you don't really have individual scripts. You can basically read the documentation. There's just one script. So it's pretty easy if you're trying to figure out where to go with FlashTalking and how to compromise everybody that uses them. They have this documentation online. There's this one script, and they compromised it. They were adding their skimming code. Anybody who loaded it up, if you were on a payment page with that script, your card data would be stolen, skimmed, sent to the bad guys. Like I said, it was really, really big. So if you look at that screenshot, it's our interface to our own web crawling data. You can see the URL at the top, which is that URL from the previous documentation. So sort of initial top part is the legitimate code, and at the bottom you see this sort of big block, lots of X's and backslashes. That's the malicious code. It's obfuscated slightly, but this is what it looks like. It was really big, this case. We published about it kind of small. We didn't put a whole lot of attention on it, but it was a big deal because they were right in the ad ecosystem, either like jump-starting ads or they were part of it, and they would, it was really, really big. We had a lot of customers affected by this one. Now, all those previous attacks were actually performed by this same criminal group. Now, we call the concept of web skimming Mage Card. It's just a name we came up with back in 2015. Because if you work on something with multiple people, you need a name to refer to it. We call it Mage Card. Specifically, our grouping isn't any fancy names. Robert had way better names than we have. We just call them Mage Card Group 1, 2, however many. This is Mage Card Group 5. They only target third parties. They never target you directly. They look at your suppliers, like with Ticketmaster, or just any supplier, basically, not specific to any target. We see them do a whole lot of shotgun approaches on suppliers, and some of them hit, a whole lot don't, but they seem to make their money out of it. So we know at least 20-ish suppliers that were hit by them. It's hundreds of thousands of websites that load up their code, but again, they don't always hit payment data. But still, if you think about it, if they're smart, why not do other things if there's no payment data? Like, I don't want to advertise and tell them what to do, but we are really surprised that they don't sort of do a check. You're not on the payment page, let's do something else. Let's still monetize it. Let's, I don't know, run scammy ads or distribute malware. They're not really in that ecosystem, so they haven't figured it out. So let's not tell them. But they can have really, really big reach. Now, I have a question if anybody knows this logo. It's sort of a lesser known version. Yeah, a couple of people. More people will kind of recognize this, maybe not completely where it's from. It's AWS, so it's the Amazon Web Services. That block logo is Amazon S3 because it's block storage. It's old logo, it's not really used that much. So Amazon Services if you're on a website, odds are Amazon is running parts of it, or at some point inside the website, maybe on the site you're not seeing, they have Amazon running something in the back for them. They are pretty much integral to anything on the web. However, their services require configurations, and if you store data or do something with configurations, odds are there's security, and with security, with Amazon S3 buckets, there's also insecurity and leaky buckets. If you look up any data breach story of the past 5 years, there will be an Amazon S3 bucket involved. People put backups in there, because you got cloud storage with Amazon, which is really cheap. So people put backups in their S3 bucket. They forget to actually set up any type of authorization. So you just go through the bucket, and it tells you which files are in there. You can just download them. It's the majority of data breaches, just because people find files, which is, at some point, is really terrible. So the access control on an S3 buckets, if you really dumb it down, if there's technical people here, I'm sorry, it comes down to read, writing, or deleting files. It's a kind of a simple system. You can give specific identity access. Identities can be user authentication, API keys, or IP addresses, however you want to identify a person. Or you can have anyone. And it sounds kind of weird, but anyone is, for example, read-only access, which makes a lot of sense because people use Amazon S3 to store static content for the website. So images, videos, all that kind of stuff. People put it in an S3 bucket because it's really cheap for bandwidth, it's really cheap to store. And if you give everybody read access, anybody can get to the data. However, that anyone access is really finicky and really dangerous because you can also give everybody write access or delete access, and you can sort of see where this is going. And you would think this doesn't happen a whole lot. Well, we disclosed a sort of still ongoing campaign, which is one of the groups we track. They focus on these insecure buckets that are sort of world writable. Anybody who visits them can modify the content in the S3 buckets. We wouldn't think there were so many, but it's thousands. It's been going on since April, and we work actively with Amazon like every day, like this morning, which is technically, I think, 3 hours ago, because I live in the US. I got an email with the new updates of the buckets that we observed being compromised. They go to Amazon. Depending on probably how well-paying a customer it is, they automatically disable it or not, and they send them messages. Please check these permissions when you go home, because people don't always use them very sort of cleanly, like directly on the website. Sometimes they use it in a process somewhere. So somebody might be messing with your S3 bucket, but you don't know until the end of your process. And the way it works, it's pretty simple. So you have the bad guy on the left. He basically goes through bucket by bucket. He checks the permissions by just trying to put a file on there. Once he sees that he has write permissions, it means he can basically play around with all the files in there. He downloads any file that ends in .js. He appends malicious code, skimming code to the bottom, and then he puts it back on the bucket. And they automate this process completely. They go really fast. Sometimes when they know they have something that's big, as in an S3 bucket that's widely used, we can try to clean it up, and you see them immediately reinfect the files. It's pretty much instant at times. And they're really good at this. They source lists of S3 bucket names somewhere. We honestly don't know. We sort of see it coming in waves, so it seems to be that they have a master list, and every once in a while they update this list with new ones, and we see new buckets affected. Now, to give an idea of impact, because it always sounds kind of far away, because I'm talking about something technical that can happen. So this is an example of an S3 bucket. You can sort of see that script block. It kind of mimics the one I had in an earlier screenshot. Again, that's the skimming code. This was a script on a sort of 360-degree panorama setup for the New World Trade Center. And that was loaded on time.com, just to give you an idea how big a reach they can get. And again, they were only skimming. Time.com doesn't process payments. It's a huge website. But directly on the website and where the code was loaded, no payment data. But think of other things they can do with having access to time.com. That's a lot of people you can do something with, distribute mail or do anything. They are heavily focused just on the credit card skimming, but we have seen groups doing fake tech support redirects, which is, in my opinion, kind of lame. It's not super interesting from a technical point of view. We've seen people play around with the idea of distributing malware. They just don't have the setup as nice as these guys, which just automatically keeps going and watches for cleanups and changes. But it's pretty big. We've seen really big websites and people that do stuff with money get affected by this. So it's not good. And in some cases, we also have the issue that it's not the S3 bucket for the website that's compromised. We had an app provider that just couldn't figure it out. They used S3 buckets everywhere. The one that was storing their JavaScript files was fine, was not writable, not publicly. However, the way that they sort of generate their ad tags, so the tags that contain the script and possibly images they link out to, is an internal process that has another S3 bucket, which sort of generates these tags and then pushes them onto the S3 bucket that's public. That bucket was writable. So they just couldn't figure out how it was happening because their bucket was fine. It was somewhere in the process that it was being sort of hijacked and modified. Now with that, it's, when you get to talk and you talk to people that manage websites, it's always kind of these moments, especially when we go to somebody who's been affected. So on a sort of general level, the basic thing is create inventory. You will have marketing department or departments that will do their own stuff. They want to have their own analytics provider because they like that one better than the other. Make like a matrix, make like an overlap. Map the functionality with the names, start crossing, and then pick one that does almost everything. If you're lucky, there's one that does everything you want. You can just use one, and then you sort of cut your entire attack surface from, if you have 10, you go from 10 to 1, for example. We've seen that. It works. And also, you need to accept that they're part of sort of your attack surface. There's more technical things you can do, which I'll also explain. But just accept that they're there and they're part of sort of a possible problem for you. And you got to talk with them, because they are in a niche. If they run, for example, a loyalty program which has an integration on the client side, they know their loyalty program stuff. They don't know security. They don't know web attacks. They don't know any of this. It's an education problem, which is generally the whole thing of what we do. We need to educate people, we need to explain things. This is one of them. Those companies have no clue at times. Sometimes, surprisingly, they're really good at it, they know what to do, but a lot of times they just really don't know. Maybe they look at OWASP and they sort of cover some of the items on the list. Very often, they don't really. Just talk with them, try to explain it. And from a technical advice, browsers don't isolate information. If you're on a web page, the same script that can move images, do anything on a web page pretty much, has access to that payment data your customers are entering. There's not really classifications in input data in browsers. I'm hoping at some point we will have that. However, you can put controls in place. They are not controls for this data and data integrity, but you can sort of control what happens on your website. So you have CSP, which are sort of a technical rule set you can use to say what can pull data, push data from your own web page. There's a lot more to it. CSP rules can get really complex. You can go down to the level of, I can include this script, but I don't want it to execute more scripts. So in case they're trying to load in more content, they can't. You can get really creative with CSP rules. There's also SRI. SRI is the concept of you know what the resource looks like before it's modified, and you can tell that to your visitor. And if he tries to pull the resource in, and it's different from what you tell them it actually is, it won't load in the browser. So it's sort of a security control. Now, don't do this automatically. We've explained this to people, and what they would do is they would live pull the resource, create a checksum, put that in the web page. So if it was modified, they would just give the modified checksum. It's not how it works. And then there's iframe sandboxing. I think iframes are very underappreciated. A lot of people kind of say, oh, it's way too old. Why are you using iframes? You can actually isolate information with iframes. We work with some really big retailers in the US, and what they do is when you're on your checkout page, the actual checkout is in an iframe, so where you put your information in. The main website sort of pulls the back end for the progress of your sort of order. In the iframe, which is isolated, cannot get data back and forth between the website, you can just put in all your information, you submit it, it closes, the main page is still checking the status of your order. If it's completed, you get redirected to the your order has been completed message. It works really well. It's a surprisingly effective method. instead of doing all kinds of like really technical controls and everything, they just isolate the information, and that's the most important part of it. So with that, thank you for listening.